Hello everyone, this is Zaida Gholami from AgriMedSoft Research Company, and in today's video I'm going to teach you how to make regression formula in Excel. But basically we're talking about linear regression. Okay, so we have focus on that, and let's see what is regression. Linear regression is the linear approximation of a causal relationship between two or more variables. So what does that mean? It means that let's say, for example, we want to see the causal relationship of precipitation or rainfall on the growth of a tree. Okay, so that relationship is the regression, is the linear approximation that we want to make here in Excel. Okay, so what we do want using regression, and actually the process we should go through, is to first have a data set. So first of all, we should have a sample data. Okay, then when we have this sample data, what we do is to design a model that works for this sample. So then, based on this sample data, we have a model. Okay, based on that. Then when this model is able to actually work for this sample data, what we're going to do in the next step is to make predictions for the whole population. So predict population. Okay, so that means that now we can have new X's and we can have the results for that X's. We can have the predictions for that input data. So the easiest regression is simple linear regression, and this is what we're gonna talk about in this session. So the formula or the equation for this simple linear regression is something like this. So we have a y here. This y equals beta O plus beta 1 multiplied by x plus epsilon. This y here is dependent value or variable. Okay, so this is what we are going to predict. This is what we're going to calculate using this equation. This is the result of our regression model. This x here is independent variable. Okay, this is something we give to the model in order to have this y. This is the input. This is actually the x. This is the independent variable. What we're going to do using this equation is to predict y having x available. So this is important. We should have this x and we do not have this y. We have this one, but we want to have this one also. That's why we do make this regression model. And another thing is that we should know that changes in x must translate to changes in y. So this is the another thing. These two are related to each other. Something happens in x, results in the happenings in y also. So the changes in the rainfall translates to the growth of the vegetables. Okay, this change affects tree growth. So let's have an example for this regression, linear regression. Let's say we have, consider this sentence. The more a guy eats food, the more weight he gains. Okay, so here what we have is the relationship between food and weight. Okay, in this sentence that I just mentioned, the food here, the more food the guy gets. So this food is X, and the more weight he gains is the Y. So here we're going to make a relationship between food and weight. Another example could be the more someone lacks of confidence, the more makeup he or she wears. So lack of confidence here is X, and makeup wearing is Y. So Y is something we're gonna predict using X. Here the weight is something we're gonna predict using X. So another components of this equation here is beta 1. So what is beta 1? Beta 1 is the coefficient which quantifies the effect of this X here on Y. So it quantifies the effect of food on weight gain, for example. Okay, so let's say this B1 here is 1.5. Okay, what it means is that for each kilogram of food that the guy eats, 1.5 multiplied by that amount of food is what he gains weight. So this is going to strengthen the effect that X has on Y. It could be 0.5. So this means it could weaken the effect that X has on Y. Okay, so it can also strengthen or weaken. But the other component here you could see is BO. So this component here is actually the constant. It means that no matter how much food you eat, you have some weight by default. So as you can see here in the equation, you know that if X is 0, then the beta 1 is also actually multiplied by 0 and it results in 0. But this beta 1 is the number which says whatever X you have, you will have some default weight by yourself, and it will just start from there. Okay, so in the graphs it's called intercept, and we will get back to this later in this video. So another component of this equation, actually the last one, is this epsilon. So this epsilon is the error of this calculation. So we have made these calculations, we have gathered this equation together, and in each process that we have made to get to this equation, we got some errors in our calculations and in our process. So this is actually mistakes that they have made. So this is the difference between observed and the prediction that we can make using this calculation. Okay, this is the difference between observed and simulated data using this equation. So up to here, you got to know what is a regression and how we're gonna actually use it and how can it help us. But let's get into this data set that I have here. You can see I have observed and simulated data and also SAT and GPA. The thing here I should mention is the difference between correlation and regression. So, correlation is actually meant to give us the relationship strength. So, this is the degree of that relationship, the degree of strength of that relationship. Okay, so correlation, this is the golden the golden sentence. Correlation does not imply causation. So regression is meant to tell us the causation. Regression is what we can use in order to see how something affects the other thing. But correlation does not tell us that. Correlation just tells us how much these two variables are connected to each other. How strong is the relationship between these two variables are. Okay, so for this observed and simulated data, what we're gonna calculate is the correlation. So this is the R squared or the Nash-Sutcliffe. But with GPA and SAT, what we're gonna calculate is the regression equation. So we're gonna say how much GPA can have effect on SAT. So let's get into this, and what I'm going to do is to calculate regression equation for these two variables. So GPA, as you probably know, is the actually scores and the average of scores of the students in college, for example. And SAT is the score of, as I know, of entrance exam to the universities. Okay, so what we're gonna do is to predict this SAT by GPA scores. So using Excel, you can have the regression formula in two ways. So if you have just one set of independent variables, you can simply have the regression formula for your data set using this charts in here. I will show you how. But if you have more than one independent variables, you cannot use this option, and you will go to data analysis, and you will use regression option in that. And I should mention that this method is more standard because it gives you more data than just one equation, and we will get to it. So now let's get to this insert tab, and I want to now plot these data against each other and get that regression formula using it. So I click on that and I go to scatter plot. Here I don't want this type actually, so let's get this data to here and delete here and make a distance. So now I will again go for here, and now it's right. Okay, so you can see my GPA is now shown as X's, and I will just make some changes to this chart. I want access titles and no data labels. So in x-axis, this is my GPA, and the y-axis is SAT. So now you can see these are shown in the graph for me. So what I will do here is to go to this plus size here. You can see chart elements is the name. I click on that and go for trend line, and click on this option in here and go for more options. Then you can check display equation on chart, and you can see the regression equation is now shown for me. So this is like the simplest way to have regression formula in Excel for the simple linear regression with one set of independent variable. So here what I mean by one set of independent variable is that you have y equals to beta O plus beta 1 x plus error or epsilon. So you do not have this one, okay? So because you could have this equation, beta 1 x1 plus beta 2 beta 2 x2 blah blah blah. Okay, so I mean you have just this equation. Okay, so as I'm working with, I know that it cannot give you this other format. Maybe I do not know that. I do not claim anything. So this is the disclaimer. As I know, it cannot give you for more than one independent variable this regression formula using the chart. So you can see this regression formula in here. The other things you can see in the chart is the intercept. So you can see, let's get into here. You can see there is a chart. Okay, so you can see the chart and you can see these data distributed. Okay, the intercept or the beta 0 is this distance. So this is beta 0. Okay, this distance. It means that every data starts from here. You do not have data in here. No, you do not have them. Your data starts from here. This is the intercept, okay? The other thing you can see in the regression line is that, so regression is basically the fittest line that you can find for your data. And in this line, the other thing you can see is the slope of this line. So the slope in here for my data is 213. Okay, so this is the slope. Graphically, this means the slope of this line. The other thing, I mentioned the intercept also, and I guess that's it. So that was making the regression formula using chart. And then we get to the more standard way for getting this formula, and that's by using the data analysis option in data tab. So if you do not see this guy right here, you need to go to File, then in Options, you go to Add-ins. You can see this Analysis Tool Pack right here. Click on that, actually select it. Then in Excel Add-ins, in Manage segment, click on Go. Then Analysis Tool Pack should be checked. If it's not checked, check it and click OK. And this will be appeared right here. So for getting the regression formula and all those data, you go on Data Analysis. This window right here opens. Then you go for Regression. Click OK. And this window opens up. In Input segment, your Y range here is the dependent variable. So we have talked about that. I do not explain more. So here my dependent variable is SAT. We want to know the relationship between SAT and GPA, and we want to know how does GPA affect SAT. So SAT is dependent variable and it depends on GPA, and this is our assumption. And then we go for input X range, and my X range is GPA. So I select that, and I made a mistake. I'm sorry. Here I should select the range with the actually labels. Okay, so I do it again, and X will be GPA with the label included. Then here you tick labels. The benefit is that when I select the label, I can check the labels and it can understand that the first row is my labels. So then here you select your output range. I want to have it started from the cell right here, and in the default mode it will generate a new worksheet and then prints the output there. So I do not want that. I do not check any other option and click OK. So here you can see this actually set of data is created for me, summary output. Then you can see regression statistics. You can see the other segments, and what we're gonna work with, it is this part specifically. So the other things actually you can see here is multiple R or R squared. Here this is like very important, the R squared shows you the correlation between these two data sets. So it implies the strength of the relationship that they have. You can see the number of observations, the standard error, and other things. And also the ANOVA and this part. So for writing the regression formula in Excel using this data analysis option, what you will do after you got these results, what you will do is to write y equals, you can see the intercept, which is the beta O, and you can see that the actually coefficient for GPA for your one and only independent data set. So if you have other independent data sets, and if you have x1, x2, x3, blah blah blah, you will get all these coefficients for all of them. So here what I will do is to put y equals, first is the intercept. Intercept here is 822.91, 822. 91 plus the coefficient for GPA is 213.23. 213.23. And then by x1. So this is your regression formula, and this is the exact formula you can see right here. You can see it, of course, gives you the same result. So I guess that's it for today's video. I hope you learned something new. Please don't forget to give this video a thumbs up and subscribe to Agmitsoft channel. I will see you in the next video, and maybe the next video I will make for you is to analyze this results for regression actually in data analysis. I will see you in the next video, and bye.